All right, so let's go on page 104 when we're done. We're going to write a couple of things at the top before we actually start going through this. So if we have sine theta times cosecant theta, right, and we want to simplify this, then I'm going to rewrite sine. What's another way I can write cosecant? 1 over sine. Good, so 1 over sine theta. And then if I multiply sine theta to 1 over sine theta, that gives me sine over sine. And what is sine over sine? 1. Okay, so this equals 1. And that is because sine and cosecant are reciprocals of each other, right? And that's how a reciprocal works. The reciprocal of 2 is 1/2. 2 times 1/2 is 1. The reciprocal of 5 is 1/5. 5 times 1/5 is 1. So when you know that these are reciprocals, we can skip this step. I'm afraid to skip it in the middle of other things just because I want you to make sure you understand why it's happening. But because they're reciprocals, I get 1. So if I have cosine times secant, what's that going to give me? 1. If I have tangent times cotangent, what's that going to give me? 1. Because they're reciprocals, and that's how reciprocals work. Okay? Now, if you do write this step, or you want to write this step, or you think you need to, fine. There's nothing wrong with it. It's just the less you have to write of this stuff, the less messy it looks, and the less intimidated you get along the way most of the time. Okay? Everybody okay with all that? All right, on the questions that we've seen so far, and from really everything I've seen from College Board, it'll say things like, simplify this to where it only has cosine and no other trigonometric expression or whatever. These questions don't say that because I didn't go through and rewrite them like that, but we still have an end goal because what's going to happen is we are going to, when we simplify them, we're going to rewrite it as a numerical expression or in terms of a single trigonometric function. So when I get down to just plain old sine theta or tangent squared theta or whatever, then I know I'm done. Okay? And again, you'll be told something else most likely, but either way, it's the same process. It really doesn't matter. All right, so here are our strategies, some of which we've already done in some examples. We can rewrite using reciprocal, which is what we did at the top, or quotient identities, and that means like to write tangent as sine over cosine. Okay? Then look for Pythagorean identities or possible ways to create one. So if you see something with a squared, that's where our Pythagorean identities come from, right? Combine fractions using a common denominator, break fractions apart, and use factoring. So these are our strategies that we can go to find this. And that's, again, one thing I'm going to kind of talk you through as we go through these. Just like a lot of things we do, it is possible that you start working through something and you're substituting things and everything you're doing is 100% legal, but it's not getting you where you think you need to go, or it's getting worse, then maybe you went down this road and you needed to go down that road. So you just back up and we start over, and it's fine. Okay, doesn't mean what you did was wrong, you're just not getting the result you want. So sometimes that happens, and that's okay. But then the more you practice these, the better you are at making the decisions from the beginning as to where to start, because that just comes with experience. All right, on number 1, my thetas disappeared. Anytime these things disappear, I have no idea where they actually go, but let's just put our little thetas back in. So really the first thing usually you want to do is look at it and say, all right, I got 2 terms. Is there anything I can factor out? Like, do you see a GCF? I don't see a GCF. I don't see anything squared, so I don't think it's a Pythagorean anything. So if you can't do those types of things, then the next one is usually to do this, rewrite it, and you don't want to rewrite everything, because if you change everything every time, then you're never going to get anywhere. But when you rewrite them, most of the time, and it depends on the question, but we're going to just change things to sine and cosine and see if that helps us. So what's a different way I can write secant? 1 over cosine. So I'm going to make this 1 over cosine theta minus, which means I'm going to leave sine theta as sine theta. And then what's another way to write tangent? Sine over cosine. Good. Yeah, it's times there. Everybody good with all that? All right, so I'm going to leave this 1 over cosine, and I'm going to clean that up. So this is equal to 1 over cosine theta minus, well, what's sine times sine? Sine squared theta. So sine squared theta over cosine theta. So now I have two fractions with the same denominator. So I already have a common denominator. I can put them together as one fraction. My denominator is cosine theta. My numerator is 1 minus sine squared theta. So now I have something that's squared, which makes me think I need to check out my Pythagorean identities. The Pythagorean identity, I told you absolutely have to know without looking at anything. It starts with sine squared theta plus what? Cosine squared theta equals what? 1. See? Didn't even need to look at anything, right? That's what you got to know that one. So if we know that that is a true statement, and it is, then could I rearrange this in some way so that I can put something different in the numerator? Okay. What? Cosine squared. 1 minus sine squared is going to leave me with cosine squared. Could I replace this 1 with sine squared? Yes, but I don't want to have to put too much stuff in. If I rewrote this, which you can rewrite it if you want to, but I'm not going to actually rewrite it, knowing this, cosine squared has to be 1 minus sine squared, so then I can make this cosine squared theta over cosine theta. And then can I reduce that? Yes, that becomes cosine theta, and I'm done. Oh, I did what? Oh, I did what? Because I solve for cosine? And that's what that is, 1 minus sine squared. No, because sine squared minus 1 would give me negative cosine squared. Yeah, I get what you're saying. Sine squared theta, if I subtract 1 over here, I got to move that over there, and that's minus cosine squared. So it's negative cosine squared. But here, if I just subtract sine squared from both sides, I get cosine squared theta equals 1 minus sine squared theta. These are two different things. No. No. Absolutely. Okay. Are we good? Yes? We sure? Okay. All right. So now any questions on number 1? Okay. Number 2. So do I have a GCF? No. And I've got nothing squared, so I'm not looking at Pythagorean right now, but that doesn't mean it wouldn't happen in the middle of it. I have a sine and a cosine, so I think I just want to redo tangent right here. So this will become sine A plus cosine A. It's just an A, like an X. It's just a variable. Yeah. So how can I rewrite tangent? Who is that? Who is it? All right, so cosine A times, well, how can I rewrite tangent A? Sine A over cosine A. Okay. So I'm going to give you a minute, see if you can reduce that and finish that one up. Okay. Whew. All right. All right. Can I cancel anything out right here? Yes. I can cancel the cosine A's out. Yes? Okay. So then I get sine of A plus sine of A. And what is that? 2 sine A. That's it. Good job. You got two of them. All right, we all good? Okay. So now let's look at number 3. Cotangent squared u minus cosecant squared u. Now, I don't have a GCF. I've got squareds on there, but so maybe I want a Pythagorean identity. I actually could factor it. It actually is a difference of squares, but that wouldn't help me any. But I know that I have other Pythagorean identities, right? So let's recall, how do we get them from this? This is the one that I absolutely have to know. If I take this and then divide each term by sine squared, so if I divide this sine squared by sine, divided by sine squared gives me 1. And then cosine squared divided by sine squared, cotangent, good. Cotangent squared theta. And then 1 over sine squared gives me 1 over sine cosecant squared theta. Cosecant squared theta, right? All right, so then the other one I get is if I take this and I divide everything by cosine squared. So the first term will be sine squared over cosine squared, which is tangent squared theta, plus then cosine squared divided by cosine squared is 1 equals, what's 1 over cosine squared? Secant squared. And so we just came up with the other two Pythagorean identities. Okay? Everybody good with that? Okay. So now here, I've got cotangent squared minus cosecant squared. So let's do this one differently than we did the one up there, meaning that I have this is solved for cosecant squared, right? So I can do cotangent squared u minus, and then I need my parentheses. That has to be 1 plus cotangent squared u with just simple substitution. And then what does that all reduce to? -1. Because cotangent minus cotangent is 0, and then minus 1. Okay? Where we could have manipulated this, and if I did cotangent minus cosine, I subtracted cosecant over here, then I have to subtract the 1 over there. But I kind of feel like if you have to do more than one thing, you might as well just substitute it in. You know, then you don't have to overthink it, and you don't have to write out a bazillion things. But either way, you get -1. Okay? We okay with that? What questions you got? All right. So then let's look at this one. There's a few things I could do. Now, I could distribute in the sine x, and I get sine times tangent and sine times cotangent, but I don't feel like that really gives me anything that I recognize. But I do have this right here, and so we are going to rewrite this, yes, but I'm going to rewrite it a different way first because not everybody gets where the tangent comes from, but yes. So I've got, if I can rewrite this as sine of x over cosine x times tangent x plus cotangent x. Would you agree that if I multiply it back together, I get the exact same thing I have above? Okay? So because of that, then that gives me sine over cosine, which does give me tangent. Wrote it like what? I can't see it. No, because the denominator then would be cosine squared. Yeah. So then that gives me tangent x times tangent x plus cotangent x. Now, it would be fine to jump to the second step because you recognize that it's tangent as long as you're doing it legally. And actually, I did that second period, and I got a lot of those blank looks, so then I redid it this way, and then everybody seemed to make more sense. So I just want to make sure I hit everybody with that. So now that I have this, now I can still distribute. This time when I distribute, it looks like it might make a little bit more sense, like it would help a little bit more. So tangent times tangent gives me what? Tangent squared x. And then tangent times cotangent is 1. Because they are reciprocals, right? No need to make it complicated. It's just 1 because they're reciprocals. We're not finished, though, because we got 2 terms. What's tangent squared plus 1?
Secant.
Secant squared. Yep. Well, it's not simplified all the way, so you're not finished. All right, what questions we got? Why are you on your phone? That is my question. Why is your phone not in the box, son? Put your phone up right now. Put your phone up. All right. Yes. Okay, so now I'm 5. I have 2 terms. I do not have a GCF. I do have a cotangent squared, but I don't know if I want to go messing with any of that stuff right now because I feel like that would just make things worse, but it might not. But I can make this into a fraction, and now I have 2 fractions and I can combine them, right? I need a common denominator. What would my common denominator be? No, I'm sorry, it's not 1. It would be cosecant, yeah. Okay. You were very confident, though. That means this fraction has to be multiplied by cosecant over cosecant, so I start with cosecant squared theta minus, and then do I need to change anything on the second one? No, then that's cotangent squared theta. Because I had to get a common denominator, so I had to multiply this by cosecant over cosecant. Okay. Now, I've got the squared, so I want to think Pythagorean. What can I replace the numerator with? 1. Yes? Wait, what? How did you get to 1? I am a teacher. I'm asking you because you're my student. How can I get 1? Jeremiah just had a moment. He can explain it to you. Look at what you wrote down over here. It's one of those over there. Oh, yeah. Oh, there we go. Because we look at this one, and this one, if I do cosecant squared minus cotangent squared, it leaves me with 1. That is where my substitution comes from. Not making up math. I didn't say, somebody else said 1, and I wrote it down because they saw it before the rest of y'all. I don't know. Somebody did. Well, actually, she did say 1. It was at the total wrong time, but she did. I mean, we'll give you credit for it. What's 1 over cosecant? Sine. And that's your answer. All right, we good with that? All right, so before we do this last one, let's, you don't have to necessarily write this down, but I want you to think about it. If I have x over 2 and I add that to y over 2, then that would give me x plus y over 2. Do we agree with that? Like, that's how fractions work, right? At least you'll know that much about fractions. I'll give you that. But if I can go this way and put them together, then I can go this way and split them apart. Okay? Because splitting a fraction is one of our strategies, and it's not something we do a lot. So it's not, I want to make sure you understand what I'm doing and why. The denominator stays with it because it's not multiplication. So if I come over here and I split this fraction, this is going to give me cosecant beta over cosecant beta minus sine beta over cosecant beta. Okay, so I have split the fraction. And I did that, I kind of jumped the gun. I don't have any GCF, I don't have anything squared, so that was kind of really I mean, I could have changed the cosecants to reciprocals, but I think that'd be kind of a hot mess right now. So that first fraction, cosecant over cosecant, becomes what? 1, okay? Then tell me, how are sine and cosecant related? What are they to each other? Reciprocals. Okay, they are reciprocals, so listen very carefully. When you multiply them, you get 1. It does not work for division, and that is a very common mistake that I see. That second fraction is absolutely not 1, okay? But they are reciprocals, so I'm going to leave my numerator as sine beta, and it goes over, and then that'll be 1 over sine beta, right? I'm just rewriting cosecant. Everybody okay with all that? All right, so then my first term is still 1 minus, and then I just keep change flip. I keep sine of beta. I change it to multiplication. I take the reciprocal of the denominator, which would then make that sine beta. And my knuckle is biting again. Okay, and so this is going to be 1 minus sine squared beta. And what's 1 minus sine squared? Cosine squared. And that's it. On the ones that we're doing right now, if it just says to simplify, you simplify it all the way down to 1 term. If you are told make it sine, make it tangent, then you do whatever you're told. What questions you got? Anything? All right, flip it over. So when I look at number 7, I do not have a GCF. I do not have anything squared, but I do have 2 fractions, and nothing reduces, so I'm going to make them into 1 fraction. So that means I need a common denominator. What would my common denominator be? Good. Sine u, cosine u. All right. So that means this first fraction has to be multiplied by cosine over cosine. So I'm going to get secant u times cosine u minus, and then this second fraction has to be multiplied by sine over sine, and I get sine squared. Now, I'm going to pause here and give you a little bit of tough love. If you have no idea what I just did, it has absolutely nothing to do with trig and absolutely nothing to do with pre-cal and everything to do with 4th grade fractions, okay? And I cannot reteach fractions every time a fraction comes up. I got a common denominator with the exact same rules that we always get common denominators with. You cannot change this to a decimal. That's why I say every time you try to do that, that's a bad idea. You have to know the rules. If the common denominator is sine times cosine, then this fraction gets multiplied by cosine over cosine. That's where that came from. This one has to be multiplied by sine over sine. That's where that one comes from. That's it. It's how you get a common denominator. Okay, so moving on with trig stuff. My denominator is going to stay the same. Sine u, cosine u. What is secant times cosine? 1, because they are reciprocals. I get 1 minus sine squared. Okay? So my denominator is going to stay the same. Sine u over cosine u. Oh my goodness, this is one of those. I don't know why these lines happen. Oh, no, my board hates me. Ah, there we go. Sine u, cosine u. Okay, back up here. Got distracted by that. Can I take this sign and reduce it with one of those? No, because there's subtraction up there. Then what is 1 minus sine squared? Cosine squared. Okay, now is it legal to reduce? Yes, so I can cancel this with one of those, and this gives me cosine u over sine u, and what does that give me? Cotangent. And that's it. Okay? What questions you got? Okay. Now, on 8, you've got cosine squared minus cosine 2 theta. There is no GCF. They are not directly related to each other. So again, you don't necessarily have to write this down. I just want to talk to you about some things here. So cosine of 2 theta does not equal 2 cosine theta. This is how they are different. On this one, I would double the angle, then find the cosine value. On this one, I find the cosine value and then double that. See how they're two completely different things? So it's not like I can take one of these take a cosine out of here or anything. It doesn't work that way. The other thing is on this particular identity, we have a cosine squared minus cosine 2 theta. If you have a double angle, that's usually what you want to try and change first. So I know this stuff is still fairly new in your brain and that you don't have them all, you don't fully understand all of them yet, and that's okay. I'm going to talk you through how we built them again so you can kind of see how we can try and remember what's what, all right? And here's what I mean by that. The double angles came from the sum identities. So, and again, you don't have to write anything in this because I'm not writing all this out anyway, but we had sine of alpha plus beta, and then we also had cosine of alpha plus beta, right? The way both of these started was with whatever this is right here. So this started with sine of alpha. This started with cosine of alpha, okay? You don't have to write this down because I'm not writing it all out. And then there's more stuff on both of them, right? There's more because it's not the actual. I don't even care what the rest of it is. But they both start with, like, sine starts with sine, cosine starts with cosine, right? Then the way we got our double angle was from this and from doing cosine of alpha plus alpha, right? Which that's where we got our 2 alpha from. So we took all these alphas and we substituted them in and we simplified things, right? So since cosine starts with cosine, I know my cosine of a double angle starts with a cosine also. The other thing, especially after you have used these more and you're a little bit more familiar with them, I'm kind of giving you like how I remember what they are by piecing them together, is that this one looks very much like the Pythagorean identity. It's not the Pythagorean identity, but it looks like it because it has the squares. So I know that if it looks like the Pythagorean identity, it's going to have this in it, right? And if it's a plus, that makes it the Pythagorean identity, and that ain't it. So that means that this has to be a minus. And that's how I kind of remember how to build it, if that makes any sense to you. Yeah, so I'm just kind of building it from my brain because they all kind of look different, you know, or then they're very similar. And we're going to redo some of these, like writing all this stuff out and showing you. I went back and forth on whether or not I wanted to do that on day one. And essentially, obviously, I chose to. But I know it was a lot of information and it was overwhelming. So once we've done this a little bit more, we're going to go back and do that again. And I think it'll make a whole lot more sense. Okay, so that's why I don't want you freaking out on it. You just got to kind of stay with me and kind of like the unit circle. We're just going to build and it'll get better and better. But essentially what I'm telling you is we're about to use this and this is what it is. If right now you better know the Pythagorean identity and all the reciprocals and stuff. This will come, right? It'll be there, but this is kind of how you could learn to build it. And then you really just have to figure out what works in your own brain because, again, our brains all work differently, but it works like that. So what we're going to do here is we got cosine squared theta minus, now remember, this is cosine of 2 theta. So I know it starts with a cosine. I know it looks like the Pythagorean, so it's squared, and this is sine squared. And then what goes right here? Minus. And then once you clean all that up, what do you end up with? No. No. Again, doesn't have anything to do with trig, doesn't have anything to do with pre-cal. How do you do order of operations and your parentheses? Cosine squared minus cosine squared is 0, and then minus a negative sine squared gives you sine squared theta. Okay? Same simplifying rules you have always used. Same algebra rules you've always used. So don't try and make it different or more difficult because it is trig. Okay? Just after the few that we have done today, do you feel at least a little bit better? Maybe just a little bit? Okay. We're going to stop here today. We're going to do the rest of these on Monday and then work through some other things.